Here are some example problems on musical scales. I tune an organ pipe to have a fundamental frequency of 421 Hertz. What is the fundamental frequency of a pipe tuned a just fifth above that? What is the frequency of a pipe tuned an equal temperament fifth above that? Well, a just fifth, as you recall, is just a factor of 3/2. So if I take 421 Hertz and I multiply that by 3/2, I get 631.5 Hertz. So there is the just fifth, all right, or the Pythagorean fifth. Now for an equal temperament fifth, a fifth is 7 half steps, so we just go up by a factor of 2 to the 7/12. So if I just take 421 Hertz and I multiply that by 2 to the 7/12 power, I end up getting 630.8 Hertz. That's equal temperament, just a little bit different from the just fifth. I tune an organ pipe to have a fundamental frequency of 220 Hertz. I play that pipe along with a pipe tuned to an equal temperament fourth above that. What is the predominant beat rate that I will hear? Okay, so this lower note, I happen to know that that is the A below middle C, and it's got a frequency of 220 Hertz, all right? A fourth higher, a fourth is 5 half steps, and it takes us up to a D. So the other note we're going to play is the D above the middle, the A below middle C, so it's the D just above middle C. You don't need to know what these notes are, just know that it's a fourth higher, and a fourth is 5 half steps. So I'm going to take 220 Hertz and multiply by 2 to the 5/12. And it turns out when I do that, I get 293.6647679. Why do I have to keep so many digits? Because when I do the beating, I'm going to be taking a difference between two very similar frequencies, so I'm going to need a lot of digits. All right, now note that a factor of 2 to the 5/12 is equal to 1.33484 and so forth, whereas 4/3 is equal to 1.3333 and so on. All right, so the point is that 2 to the 5/12 is really close, but not quite equal to a factor of 4/3. All right, so the just fourth would be going up by a factor of 4/3. The equal temperament fourth is going up by a factor of 2 to the 5/12. So the fact that we don't exactly go up by a just interval means we're going to get beating. And in particular, we expect that I will get my predominant beating, most likely, between the third harmonic of the upper note and the fourth harmonic of the lower note. So my beat rate, then it's just going to be the absolute value of 4 times the frequency of the A minus 3 times the frequency of the D. All right, and if I plug those numbers in, all right, here's my frequency of my D, my frequency of my A. This turns out to be equal to 0.994 Hertz to 3 significant digits. All right, so almost a Hertz, almost exactly a Hertz. Now I could verify that by pulling up Temperament Studio, right? If I turn on Advanced Controls, let's see, I can show the frequencies of the notes, all right? And you see right here, 220 Hertz is the A below middle C, and here is the D above middle C. We said that's 293.664. There it is, all right? So let's play these two together. I should hear beating at 0.994 Hertz, so about a Hertz. That's about a Hertz. All right, I could actually measure this, get a stopwatch, listen how long it takes for it to beat, 50 times, and then divide by 50 or something like that. And I could measure that beat rate precisely. I'm not going to do that now, but it did sound like it was about a Hertz. By timing it, I could see if I got the right answer, if I did something wrong.